This is the EPS Infosewer program, and now we're going to look at the advanced force main solution for EPS simulation. If you remember from the previous advanced force main video, you turn on advanced force main by going to the general tab and turning on advanced force main support and optionally flow attenuation. So we go ahead and run this, and it gives you an overall continuity error, and you want to make sure that the inflow equals the outflow, and a 0.17% is a good continuity error. So this is basically a dendritic force main, and it's the same force main that we ran with the EPS. Now let's make this a little bit more complicated, and we're going to activate this upstream pump and this side branch force main and this cross force main. So with the advanced force main support, we can have upstream pumps going to the same chamber node. Remember, this is a chamber node. We can have bifurcation coming out of a junction manhole to two separate force main solutions. So the difference is that between steady state force main and steady state, EPS force main and EPS no force main solution is that there's more iterations and you get a better answer with the advanced force main solution. So let's go ahead and run this, and we have our continuity error again, and let's graph the force mains. So click on the attribute browser graph, come up with this. Let's remove all these graphs and let's do a group graph. We'll do a group graph of all the force mains. And here's all different force mains. Okay. Remember, if you click on report, we can see the various bits of data. We can get flow, velocity, head loss, and sediment. So here's our different head losses going through here. Sediment was because we were doing water quality as well. Let's look at the group chamber manholes. And here we have the grade. Basically, you get the grade in the chamber manholes. Okay. Let's look at the graph or the reports now for gravity main reports. We're going to look at all the gravity mains, which are the blue lines here. And what we get is the peakable or the peaked values. So here's our maximum flow time, max velocity, max water depth, Froude number, the maximum D over D, the maximum overflow, which is the extra flow coming out of the gravity mains, the adjusted D over D. Remember from the previous discussion, there's a two-pass solution. The first pass is to put the flow from the loading manholes into the pipes, and that would be the D over D value. The adjusted D over D is when you have backwater or other conditions that are occurring. In this particular case, all the pipes are full, so the D over D and the adjusted D over D are essentially the same. So, and maximum Q over Q. Okay. All right, let's look at a profile. So let's go to graph, pipe profile. So we'll look at the pipe profile here. Look at a few examples. And this shows you the profile going through the system. And if you notice it's going off the screen, it means that when the force main, basically Infosewer is a master planning model, and it pushes as much water as possible through the system. So there's no overflow occurring at the nodes as would be in InfoSwim or ICM, or InfoWorks ICM. So this is a little bit about the advanced force main solution. It allows you to have more complicated force main additions or force main connections than you can have using the EPS. Now what would happen if we turned off the force main solution? So go here to the force main solution, turn it off, we try to solve it, and again it gives that same split flow configuration. You can't have bifurcating force mains without the advanced force main solution and considerations. So thank you for listening, and I hope you learned something about the Infosewer advanced force main solution.